Okay, so this is your video going over the formative assessment. What you're going to want to have, you're going to have your paper assessment out and then pull up the self-assessment and follow along with that notes to self section in the video for how you did on each thing. Hopefully you have already listened to the feedback from me and looked at which ones you got and which ones you didn't. Okay, let's dig in. 1A. Rewrite the equation on your paper. Label each species in the reaction as an acid or a base. I got a lot of people just doing this. Okay, that is not each species. You have to do everything, okay? So again, think about what is acting as an acid and what is acting as a base. So the water is gaining a proton. So this question was checking to see if you understood our definitions there. Okay, B, you need to connect the pairs. We're still having some issues here. So remember that conjugate acid-base pairs are one proton away from each other, one H plus ion, okay? All right, so then C, is the reactant strong or weak? Most people got this right. They said, hey, that's strong. And then specifically, some people just said, well, I know nitric acid is strong. Great. But when I ask for, hey, how do you know this from the equation? Really, it fully ionizes. And we can tell this from the full forward arrow right there. Okay. Looking at 1D, is the conjugate base strong or weak? Okay. So to do this problem, you need to recognize that the nitrate ion is the conjugate base. Okay. And then what you also need to know is that the conjugate of a strong acid is extremely weak. Okay, it's negligible. It almost does nothing. Okay, so you need to know this relationship. Very important. Okay, on to E. Here's what we're looking for. We're looking for the same number of hydrogens, okay? And then the other thing I needed from you is you needed to show that you understood that these were protons, that overall these things were charged. So if you didn't have the charges on there, I did not give you credit for the problem, okay? So same number, and you need to have them shown as charges. And one thing to remember is you just draw ions as circles. Okay, we don't need to draw out Lewis structures. You don't have time for that. So don't do it. You're not going to, there is no extra credit on the exam. There are no bonus points. So you just need to do what you can with the amount of time you're given. Okay, this was the biggest problem for everybody. What is the pH of this solution? And all you have been told is that the concentration, let me scroll up here really fast, the concentration of HNO3 is 0.30 molar. And a lot of you started doing all of this equilibrium math. You started doing ice tables. No, no, this is a strong acid, right? It fully ionizes. So all of this goes away. All of those ions become hydrogen ions and nitrate ions with the same ratio. So the concentration of hydrogen ion is 0.30 molar, okay? And some people on their exams wrote, you didn't give me the Ka. And it's like, yes. And that should indicate to you that you are on the wrong track if you're doing this on the exam, okay? So you're like, oh, I need this. If they don't give it to you, there's probably a different way to do it. So you need to take the negative log, which most people are really good at, of 0.30 to get the answer here, which means it is a pH of 0.52. Okay, and then G, we also struggled on this one. So again, if you're, a lot of people found the POH and then went to hydroxide ion concentration. I like to do it using Kw because remember, Kw is equal to the concentration of hydroxide ion multiplied by the concentration of hydrogen ion. And Kw is 1.0 times 10 to the negative 14th. So if we're solving for the concentration of hydroxide ion, we can just pop our 0.30 molar in there for hydrogen ion, solve for hydroxide ion, and I got 3.3 times 10 to the negative 14th. And then do make sure you get your units on there. Some things I've been missing. A lot of you just labeled one. You didn't label all the letters. You need to label all of the letters from now on, okay? And just make sure you're getting your units on stuff like that. So that's question one. Okay, and let's, I think I can erase, let's see, I don't know. Woo! Or I can just move Oh, I'll just move down. Okay, cool. Let's go into 2. Okay, 2A. People did a great job on this question. We got the KB. Just always remember you're not going to include water because of that heterogeneous equilibrium, right? So we don't need it in there. So this is what you should have gotten. Okay. And I kind of mixed this up on you. I did a KB just to rock our worlds a little bit. Now, 2B was the big problem, and I got to say, you all shined. So what you needed to do was set up an ice table, which people were good at. Okay, ICE. You said we started with 0.22 and you recognize that we had none of that. Plus x minus x minus x. So this is 0.22. Oops, sorry, I did that backwards. Minus x plus x plus x. 0.22. Why can't I write that today? Oh my gosh. Let's erase that. Sorry. Trash that whole thing. Okay. 0.22 minus x, x, x. Okay. Can we ignore x? Well, the KB is 1.8 times 10 to the negative fifth. Those are far enough away. We can ignore x. So we need to set this back up. Use this equation up here. So we're going to get that KB is equal to x times x because I'm plugging these in, and then all over 0.22, and that is equal to that 1.8 times 10 to the negative fifth. Okay, so you should have gotten that x was equal to 2.0 times 10 to the negative third. To get the pH, it's just the negative log of that number. Okay, and when you get that, you get that the pH is equal to 2.70. Then on 2C, people did a nice job with this. They said, hey, the relationship between that is pOH is 2.70 because that was the negative log of the hydroxide ion concentration, okay? And then to get 2C, our pH should be 14 minus the pOH, because that's the relationship there, and this is on your reference sheet, okay? So you should have gotten that the pH then is 11.30. Okay, D, what are some things that tell us that this is basic? Well, hey, look, the pOH is low, the pH is high. We have a lot more hydroxide ion in concentration or in our solution than hydrogen ion. Lots of things to use to support that. People did well on that. Okay, E. People struggled on E because what you didn't do, you had a test freak out and you weren't sure how to go from KB to KA. And what you need to do is you need to go look at your reference sheet and say, okay, oh my gosh, do I have any equations that relate KA and KB? And you actually do. And you don't have to memorize them. You just have to know how to use your sheet. So KW is equal to KA multiplied by KB. We know KW is 1 times 10 to the negative 14th. This is also on your sheet. We've already been told KB. It's 1.8 times 10 to the negative fifth, which means we just need to solve for Ka. So take 1 times 10 to the negative 14th, divide by 1.8 times 10 to the negative fifth. You should get that Ka is equal to 5.5 times 10 to the negative 10th. Boom. All right, carrying on. F, you should have picked B. Why should you have picked B? Because it doesn't have to be a perfect model. And I know some people picked A because, oh, KB is so small. But if you're using a model, you should have picked either B or C to show equilibrium, okay, to show that there's both reactant and product. And then why should you have picked B over C? Well, C showed a lot of product. And you need to always be thinking about what K means. So this KB is 1.8 times 10 to the negative fifth. If it's way smaller than 1, that means there's a lot more reactant in the denominator than there is product in the numerator. So we should have picked B because it shows much less product. Okay, on to the stretch problem. Okay, so hopefully we're doing better at this. We've reviewed this in class. 3A, I had you look at formic acid, which is something we call a carboxylic acid. This is the simplest carboxylic acid, or the simplest carboxylic acid. Yep, that was a Science Bowl question recently. Okay, and this freaked people out. Okay, because it wasn't written like. Let's erase just really quick, or can I just use my erase? Oh my gosh, that's so nice. Okay, using my new pen. Okay, so because it wasn't written like that. So I think a lot of people were just thinking about acids bases and they were like, oh, that OH stays together and it's just a hydroxide ion when it comes off. No, 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 no. It's really hard to remove this carbon and oxygen from each other, okay? So when we look at these two hydrogens, we're comparing this hydrogen connected to the carbon and this hydrogen connected to the oxygen. And when we are comparing these, carbon and oxygen are in the same period on the periodic table, so their bond lengths are going to be pretty similar. Now, what we're really comparing here is electronegativity. Oxygen is a lot more electronegative than carbon, meaning these electrons in this covalent bond spend a lot more time with the oxygen. This is a lot closer to being an ion. So when this loses a hydrogen, it is actually this one, okay, that comes off because oxygen is more electronegative. So that description is B. C, people did an okay job. Here's what I saw from people most commonly. This is what I saw a lot. Why is this wrong? Because formic acid is not one of our 7 strong acids. So you have to have equilibrium arrows on C. Now D, now that we've done all this work with buffers, I bet we would be okay. But basically what we're seeing is it should ionize less, okay? According to Le Chatelier, right? Common ion, shift left towards those reactants. And I know I was kind of just trying to come up with a problem to have you draw some things to visualize stuff. So I think what I was really looking for was for you to show that, hey, they have a common ion. You can see that the sodium acetate makes this ion. The acetic acid also makes that ion. Oh, look, they're the same thing, and comparing it there. Okay, if you have questions, let me know. Make sure to fill out the rest of your self-assessment, and you can watch any part of this video again. Nicely done, everybody.